Hi, I'm Madison, and today we'll be discussing the effect of hydroxyapatite particles when treating prostate cancer. So the type of nanoparticles used in this experiment, they used hydroxyapatite or HAP nanoparticles. The general size range of these particles are from 0.1 nm to 100 nm, but the experiment specifically used nanoparticles that had a diameter of 40 nm. The shape of these nanoparticles wasn't explicitly stated in the actual article, but they are typically either spherical, rod-like, or needle-like, and this depends on the pH level. And however, the article does mention that it the AGP treated cells became round, distorted, and small as well. Image A, as you can see to the right, shows how these different cells were treated with HAP at different levels from 100 to 200 to 400 micrograms per milliliter over the course of 48 hours. Now, in this experiment, they also did it over the course of 24 hours, 48 hours, and 72 hours with different density levels. And we could see how the particles helped affect the prostate cancer. And image B also shows that in more depth.
So for the application of nanoparticles, the hydroxyapatite nanoparticles, they were used to show to see how they could affect prostate cancer and more so specifically treat prostate cancer. They did this because they've seen that the hydroxyapatite nanoparticles have been seen to prevent growth of certain tumors. So they use that same logic to see if it would apply for prostate cancer. Because prostate cancer is becoming the most common cancer among Americans, so trying to cure it is becoming more and more important. And it's growing at such a fast rate. One of the countries that is increasing the most is in China. And for application, the biggest application of hydroxyapatite nanoparticles was in cancer treatment, specifically the prostate cancer. So it's pretty important in prostate cancer. And after seeing how it treats and affects prostate cancer, they can apply that knowledge to other deadly cancers and see if they can cure them.
All right, so what the nanoparticles did, the paper did not specify a specific mechanism by which they killed the cancer cells. However, the nanoparticles did very obviously cause large-scale cancer cell death through apoptosis. You know that's apoptosis because if you look in the on figure one, the one with HAP, all the cells are distorted and irregularly shaped, which is a telltale sign that they went through apoptosis and are dead or dying. The paper hypothesizes that this is caused by the nanoparticles stressing the endoplasmic reticulum because when they tested the cells, they found the presence of a caspase 12 enzyme, which is only released in cases where the endoplasmic reticulum is stressed and it's designed to cause apoptosis in case of cell like issues with the endoplasmic reticulum. Yeah, and if you see on the bottom right, the cells, the top one is through a they're both through microscopes, but the top one is just normal lighting, and then the bottom one has a fluorescent dye added, so you can more easily see the dead and dying cells.
So advantages of hydroxyapatite nanoparticles are they decentralize well, which basically means they maintain stability and they provide prevent aggregation, which is just a lot of cell growth. And they also have a strong inhibition ability. So whenever they were using the hydroxyapatite nanoparticles for tumors, they saw that it helps prevent excess cell growth, which pretty much is cancer. Hydroxyapatite nanoparticles are also easy to prepare compared to other particles, and they have good histocompatibility and absorbability. Some disadvantages of current technologies, though, is that it can be pretty expensive and that it's constantly changing, so there's always a learning curve and you constantly have to adapt. But nanoparticles are definitely improving the search for different problems, such as prostate cancer. It's becoming more efficient because there's just so many different ways you can improve medicine. So because of nanoparticles, they were able to find a pretty effective cure for prostate cancer. And the nanoparticles can improve the search as well because once you get one cure for cancer, you can kind of apply that same logic and approach to other cancers and other medical problems. And there's also a lower risk factor when you have more technology because you have more knowledge compared to just doing it without really not having that background. So it definitely helps making sure you know what you're doing when you're trying to find the cure. And then this is the article we used in our references. And then this is just a statistic about prostate cancer and how it is the leading cancer in America.